In this second part of our discussion about built-in, special, and custom functions, we're going to continue describing some of the built-in and special functions that we started in part 1. So here I'll leave you with the worksheet. The function diff is equivalent to the derivative that we have over here. You can take a second, third derivative if you use the third argument here. And so if I wanted to type this derivative, I will type diff parenthesis 1 minus x squared space bar times cosine of x space bar comma x control dot, giving me this result. If I wanted a second derivative, I would type something similar, diff 1 minus x squared space bar times cosine of x space bar comma x comma 2, let's say 3. Oh, I typed the equal sign. I need to do control Z and then control dot, and that it will give me the third derivative of that expression. Eval, this is used mostly in programming because the tendency for SMath Studio is to do a lot of operations in symbolic form. These will turn them into numerical form, and so that will accelerate the processing time if you have a lot of operations to do in your program. The gamma function. The gamma function is a mathematical function defined in this manner. Gamma of x, the x is the exponent of this z, and the z is involved in this integral from 0 to infinity. It turns out that if x is equal to an integer n, the gamma function of n is the factorial of n minus 1. To find those values, you just have to type gamma con uppercase G, sorry, to begin the calculation, and you get the gamma function. But the gamma function that is defined in SMath Studio only applies to positive numbers. There is a formula from mathematics, this formula that would allow me to calculate the gamma function for negative numbers, because if I put x to be less than 1, for a negative number, this will give me a positive number, and then I know how to calculate this gamma. All I have to do is create a function that I'm going to call gamma. This gamma is entered as G, control G. And so as a conditional, if x is greater than 0, calculate gamma x as defined by SMath Studio, else calculate the right-hand side of this equation. And with that, I'm able to extend the gamma function to negative numbers. Int is an integral. This integral, int x times ln of x space bar comma x, is an indefinite integral, but there is no table of integrals in SMath Studio, so if you do control dot, you just get the same result. The only use for this expression then is to document some mathematics in your worksheet. The numerical integration is available if the limits are numeric. So if I type this one, I will type int parenthesis x times ln of x space bar comma x comma a comma b. I type a z there instead of a. If I want to calculate that with equal sign, I won't get anything because it's not numeric. The values of a and b are not defined. I'm going to do control Z here and do control dot. And all what I get is the repetition of the symbol. So basically this integral, although definite with symbolic limits, it's just only going to be useful for documenting mathematical expressions. But this one right here actually gets calculated numerically, and that will be just int of x times ln of x, comma x, comma 1.5, comma 2.5 equal, and that give me a particular numerical result. Next, we have the function isDefined, which is used to determine if a variable has been defined before. For example, b equals 5 right here. If I type isDefined b equal, I get a 1. And 1 in SMath Studio means true. 0 means false. Is C defined? No, it's false. If I clear B here and check is defined, it will give me 0 because it has been cleared immediately above. The Jacobian. The Jacobian, if I have a vector function, f1 of x, f2 of x, f3 of x, and I define my variable, a vector variable x, x1, x2, x3. Notice, however, that my one in here is a subscript, so I type f dot 1 parenthesis x. Okay. Whereas these variables are actually elements of the vector x bracket 1 and so on. If I try to find the Jacobian of the function f of x with respect to x using control dot in here, I get the definition of the Jacobian. Now, this should be partial derivatives because x is a function of 3 variables. It's actually a vector with 3 variables. So in reality, this should be partial derivatives, but SMath Studio doesn't have the partial derivative symbols, therefore it's indicating total derivatives. But the idea is the derivative of f1 with respect to x1, f2 with respect to x2, and so on. It's a vector. If I have my functions defined this way, but elements is in brackets, and this is my definition of the function x, the Jacobian of this vector function with respect to this vector of variables is going to provide these. Then we have the function product. That will give me a numerically calculated product. All you have to do is type product, the function you want to multiply, and index. By the way, this function is a function of the index k. The beginning and ending index. And so let me type another one like product. Let's see, k square, comma, k, 1, 2, 3. Okay. Sum, this is for documenting. Sum on a function of k. And then a sum, this is similar to the product. And then we have units, numbers of. This one is somewhat useful. All you have to do is type units of, type a quantity with units, and it will give you the basic unit in the SI. It's probably useful in programming. I cannot see any other application here. Now, if your unit is in the English system, like 5.2 feet, it will return the SI unit. BTU is a unit of energy or work, returns joules. Pound force is a unit of force, returns Newton. We're going to stop the video right here and continue with the plugins recommended in the next video.